With regards to Markforged 3D printing, just as an example of materials to work with, they have two different materials that you can print in. One is nylon white, similar to like a nylon 6. Their other is a proprietary material called Onyx. Onyx is think about it as like an 80-20 blend of 80% nylon, 20% chopped carbon fiber. Again, really great materials. They layer down in up to 50 micron layer resolutions, so you get really super clean parts, tolerances that are really super tight, and again, non-marring materials, and they're excellent for manufacturing applications. Again, we use them all the time, but one of the cool things that Markforged brings to the table, and I really wanted to mention this and drive this home because it's unique to Markforged, and it's one of the things that really attracted CamLogic to working with Markforged when we became partners with them years and years ago, is that you can embed continuous fiber material into your part. And I know that's kind of a like, head scratcher idea. So what do you mean? What are you talking about here, Rob? Well, the idea is that you can embed into your part at, say, layer 50 through layer 52. I know that there's stress on those layers, and I want to put carbon fiber into my part, or I need my part to bend, so I'm going to use Kevlar, or I need a little bit of reinforcement. Fiberglass will work. And the idea is you can actually put these materials into your parts so that your parts are stronger, or they can bend better, they wear better. And I always likened it to just saying, hey, it's like the same way when you build a freeway, right? If you're putting rebar into your highways are going to last a lot longer. They're going to be a lot stronger. You can have really big semi trucks with a whole lot of payload drive over it. You're okay. You take the rebar out, your road gets beat up a whole heck of a lot quicker and doesn't last as long. So again, it's a pretty unique concept that Markforged brings to the table with regards to being able to embed continuous fiber materials into your part. Each fiber material does things that are a little bit different from the other. So again, it's very important to understand what your application is to choose the right materials for your part. Kevlar is great for wear applications. It's got a lot of flex to it. There's a high heat, high strength fiberglass out there, which is great if you're doing, say, like weld fixturing, things like that. Carbon fiber is really where you start taking the steps of, wow, my part is ridiculously strong. In many cases, your part is stronger than aluminum. So oftentimes when we're doing trade shows, customers or folks at the trade shows will come up to us and say, well, hey, can you print in metal? I need my parts in metal. Well, our natural response to that is, well, why? Oh, I need my parts to be really strong. Well, okay, well, what if you can print in plastic and it costs a whole heck of a lot less, and the tolerances are where you need it to be, and in many cases it's stronger than aluminum. Would that be okay? And I don't know what it is. It's just because we've been doing it for so long at CamLogic, but that concept seems to really blow people away. So again, I really wanted to mention that to everybody as we're moving along here. Another thing I wanted to mention with pertaining to materials and the controls that you have with your materials. There are 3D printing softwares out there that allow users the ability to orientate your builds, allow users the ability to understand how their part's going to print, how long it's going to print, the costs associated with it, the controls for, do I want my part to be sparse filled because I just need a prototype and I need something very fast and I don't need a whole lot of infill to it, or I need something that's super, super tight and I need to tighten up my infill. All of those controls come in Markforged's case with their Eiger 3D printing software. It's a great software. It's really easy to use. Comes with the purchase of every machine, so there's no like maintenance costs, and you don't have to install it on networks. It's all cloud-based and cloud-driven. So again, tons of controls when it comes to really understanding how do you optimize your material. And again, this is important to take into account too. If you're building your part in, say, the Y direction or the X direction, or understanding how do I orientate my part with the build itself so that if I have a lot of compression, or I got a lot of strain, or I got a lot of pull on my part, right? You need to be able to orientate your part to optimize those material strengths. So again, really important to understand how all this works, and if you really do, you can optimize your material strengths and the amount of capabilities that come out of the materials that you're working with. So this is important, and this is something where for CamLogic, we're really, really good at this. And this is where we really take a lot of pride in helping our customers, right? And don't think about this in with regards to just Markforged. Think about this with regards to any 3D printing material that's out there. Because again, we can print in lots of different polypropylenes to rubber-like materials, everything across the board. But you need to start asking yourself before you go through a project or you say, oh, my company's really interested in 3D printing. We're just going to print these gripper arms in Onyx and see what happens. Well, no, you don't want to do that. You want to take into account, well, what is my application and what are some of the things that my application is going to see? Am I printing a part that is going to see a lot of heat to it? Am I printing a part that maybe, for example, has to be food grade, if that's important? We've had customers that are, print automation or manufacture automation machines that, are putting food products through it. And their customer says, well, look, we'd love to use 3D printing to do this. It would make life a lot easier, be a lot cheaper. Materials are strong enough, but did the FDA certify that we can use these materials? And in many cases, yeah, there are materials out there and we've printed them and they're great. But those are things that you want to take into account, because like in that example, there's no sense in printing 400 parts and then finding, well, the certifications aren't there and we just wasted a lot of time. So go through the process, ask yourself what's important, and if you find yourself scratching your head going, I don't know about this, ask us. That's what we're here for. We'd be more than happy to help. And again, got lots of experience in a lot of different materials, and I have a full team that's more than happy to do the research for you. So again, challenge us, we're here to help. Data is king. So when you're looking at your parts and what it is that you're trying to do, again, if it's a reputable manufacturer of FDM materials, every material should have a data sheet to it. So you should be able to understand how much heat deflection, for example, will I get out of my part if I'm doing, say, a under the hood component, or I'm doing weld tooling. We've had customers that we've worked with that have done molds that you pour like a foaming agent into. Well, okay, that's cool. You can print the mold and I can pour my material into it. That's great, but you got to clean that mold. So if you're using an ammonia-based material, or if you're putting chemicals in there, it's important to understand how your material is going to hold up to those chemicals. So again, by all means, ask for data sheets, look for data sheets. CamLogic, we don't do anything unless we have one of these. So again, it's important, and again, if it's a reputable manufacturer of materials, they will have these for you.